All right, welcome to lesson 5.3. So we're going to use, the objective is we're going to use the vertex form of a quadratic function. So up until this point, we've talked about the standard form of a quadratic function. So to recall, standard form is squared plus bx plus c. Vertex form is a times x minus h squared plus k. If you notice, the a's are the same. Well, the a's are going to be the same. They're going to tell you the same information. What's interesting about the vertex form is that the vertex is the ordered pair hk. Notice how the function is minus h. So that means if it's minus when they're actually numbers, well, we'll talk about this in a second, but take note that it's minus in the form. So for this one, now we're going to look at properties of a graph of a quadratic equation in vertex form. The graph of y equals a times x minus h squared plus k is the graph of the parent function y equals ax squared, translated h units horizontally and k units vertically. So whatever's happening inside the parentheses, it's going to move it left or right. Whatever's happening outside is going to move it up or down. When h is positive, the graph shifts right. That's a little confusing because, again, notice that it's minus in the function. So a positive h means it's going to show up as subtraction. When h is negative, the graph shifts left. H is negative if h is negative and you're subtracting a negative, then it's going to show up as addition. So the way that's phrased is a little confusing, but that's why. All right. When k is positive, the graph shifts up. That works the way you think it should. That would be addition. When k is negative, the graph shifts down. That will look like subtraction. So the vertex is hk, and the axis of symmetry is the line x equals h. So when you're given a function in vertex form, you can get the vertex and the axis of symmetry without doing any calculations. You just pull that information out and you can use it. Then you'll just need to find a couple other points. So let's go through the process here. The first thing I'm going to notice is that the vertex, see how it's minus 1? That means the vertex, the coordinate is 1. And then plus 4 means that the y-coordinate is 4. So I can go ahead and plot that point. So write 1 up 4. The axis of symmetry is going to be the vertical line that cuts through that. So the axis of symmetry is going to be x equals 1. And then you just need to find two other points. So the y-intercept is not available like it would have been in standard form. So that plus 4, again, is the y-coordinate of the vertex. It's not the y-intercept. So if I already know the vertex is there, I'm going to pick another x value. So I might go one on the right or one on the left. Doesn't matter which direction you go, whatever number you think is easier. I kind of like picking 0. So when x equals 0, I'm going to figure out the y value that goes with it. So 2 times 0 minus 1 squared plus 4. 0 minus 1 is negative 1. Negative 1 squared is 1. So you end up with 2. And then plus 4, you end up with 6. So the ordered pair, when x is 0, the y is 6. So that point would be here. And then it would reflect to here. At this point, I'm just going to draw my curve because any other points I would plot would be off the grid, right? So normally I would pick another value of x, but for this one I don't need to. Let's do the same thing here. So now the vertex, notice how it's plus 1 there. That means the x-coordinate is negative. And then the y-coordinate is based off that minus 2. So I've got left 1, down 2, for my vertex. My axis of symmetry is going to be x equals -1. Now I just need to pick a couple other points. So you kind of have a couple choices here. I might pick the one point to the right, but the a value being 2/3 makes it a little more complicated, but not horrible. So you might want to choose to pick something that will make that fraction clear out, meaning if I can get x plus 1 squared to be a multiple of 3, that would actually be pretty ideal. So let's try that. So I'm going to pick an x value of 2. And the reason why I chose 2 is because 2 plus 1 is 3. And then when I square 3, I get 9. So again, I'm picking 2. 2 plus 1 is 3. 3 squared is 9. So now I've got 2/3 times 9. The 9 will cancel out with that 3. So now I've just got 2 times 3, which is 6, plus 2, which ends up being 8. So the ordered pair is 2, 8. So if I go and plot that point, I go right 2 and I go up 8. This grid actually only goes up to 6, but I can kind of estimate that it's there, right? And then if I plot, go the other direction, opposite side, you got that. And I can kind of draw my curve through that. Again, you can pick another value of x if you'd like. It's going to end up being a fraction, which is okay, but generally speaking, that's good enough. You can also use the vertex form to write the equation of a parabola. So if I have a picture, a graph, I can use that information to write the equation. So remember, the form of the vertex function, well, the form of the quadratic function in vertex form is y equals a times x minus h squared plus k. So essentially, you need to know the a, the h, and the k. Well, looking at the graph, I mean, this is spelled out for you, but even if it wasn't, you could see where the vertex is. It's giving you 2 out of the 3 things that you need. So the h is 2 and the k is -5. So it's x minus 2 again, because h is positive, it's minus a positive 2. And then plus k. Well, if k is -5, then it's minus 5. The last thing we have to do is figure out the a. What I'm going to do is just pick any other point on the graph and substitute those ordered pairs, that coordinates in for x and y. So if I use this point, and I don't have to use this one, I'm just using this one because it's labeled, but I could have picked, that point there. I could have picked, I think, that point there or that point there. So any of these would have worked. I'm just going to use the one that's already highlighted. So I'm substituting 0 in for x and -3 in for y. So then -3 is equal to a times 0 minus 2 squared minus 5. Now I only have one variable, a, and I'm going to solve for a. So the first thing I'm going to do here is, well, 0 minus 2 is -2. -2 squared is 4. So now I've got -3 is equal to 4a minus 5. Now I'm going to add 5 to both sides. So now I've got 2 is equal to 4a. Divide both sides by 4. And you end up with a is equal to 1/2. So that's your a value. So now I'm going to go back to this point and substitute the 1/2 in for a. So I've got y is equal to 1/2 times x minus 2 squared minus 5. So I have substituted in now for the a, the h, and the k. I'm leaving the x and the y because that's now the generic equation for the entire curve. All right, so there you go. You have some others to try here. I'm going to leave those as part of the exit ticket. you can convert a function from standard form to vertex form. So you're just going to find the vertex, and then the given value of a is a. So the process that we used in the previous lesson to find the vertex, we're going to do the exact same thing here. So the x-coordinate is the opposite of b over 2a, right? If that's the a, that's the b, and that's the c. We're not going to use the c, but that would have been the c. So 12 goes in for b. So the opposite of b would be negative 12. A is negative 3. So you end up with negative 12 over negative 6, which ends up being 2. So that's your h value, because that's the x-coordinate on the vertex. I'm going to now substitute 2 in for x and solve for y. So negative 3 squared, I'm sorry, negative 3 times 2 squared plus 12 times 2 plus 5. 2 squared is 4 times negative 3 is negative 12. 12 times 3 is 36, and then plus 5. Negative 12 plus 36 is 24, plus 5 is 29. So now I know my k value is 29. And then the a value, the only other thing I need to write the equation, is the same as the a value in standard form. So it's negative 3. So now when I put it all together, remember I'm using a times x minus h squared plus k. Well, my a is negative 3, my h is 2, my k is 29. So the answer to this one would be y is equal to negative 3 times x minus h. H is 2, so minus 2, squared plus k. K is 29. So that would be the vertex form of the equation that was originally given here in example 3. There's another one left. I'm going to leave that for the exit ticket. When you write an equation in standard form from vertex form, essentially you're just doing the operations you need to do to break it all open. So for this one, the first thing I would do is FOIL the x minus 2 squared. So essentially what you've got is x minus 2 times x minus 2. Those are going to get FOILed together. So you got x squared minus 2x minus 2x plus 4 minus 2. Now I'm going to combine like terms. X squared minus 4x and then plus 2. So now this is the standard version of that vertex version of a quadratic function equation, I suppose. So yeah, you just FOIL and then break it out. I'm going to leave the last one there as part of the exit ticket. However, I will point out the difference is you got that negative 3 as an a value. What you're going to do is you're going to FOIL these together, all right, and then multiply the negative 3 into that, distribute it, and then add the 1. All right, so a little hint there. And that's it. So the exit ticket is posted in Google Classroom. Give those questions a try, and then we will go over them together. Let me know if you have any other questions.